All right. Thanks everyone so much for joining today's Tech Tuesday. As you can see from the title, Corda OS has now been made GA on Kaleido, meaning you can now run Corda in the scope of a business or an enterprise tier subscription. You can decentralize your network, span multiple clouds, actually have external autonomous participants, and then you can leverage sort of our enterprise contracting structure, which gets you an SLA. We are offering some special packages for early stage Corda pilot and proof of concept programs. I'll touch on this again at the end, but just want you to have that in your back pocket if that's something of interest. And we're also offering a closed program for sort of a more expeditious route to run and host your core dApps. So again, I'll touch on that at the end as well. I'm going to skip the slides for today. Typically, we just run through Kaleido at a very, very high level. But what Kaleido is really, really good at is taking all of the hard infrastructure pieces off of your plate. So all of the runtime components, all of that low-level peer-to-peer messaging, all of the crypto primitives. Kaleido is going to do all of that for you and give you those enterprise-grade levels of high availability, disaster recovery, auto-scaling, and best-of-breed open-source technologies. So when you come to Kaleido, we are your blockchain-as-a-service provider. But we're also the one-stop shop for all of the components that you need to build out your Ethereum or your Corda solution. So we try to make it really, really easy for you to get into, quickly a pilot or even a production phase, again, without having to concern yourself with the low-level primitives and the things that are really, really hard. Kubernetes, high availability, HADR, you name it. So that's Kaleido in a nutshell right there. What we're going to do now is just hop directly into the product, into the console, and we'll go ahead and create our own Corda network from scratch, running on our enterprise tier subscription. So you'll see the ability to be able to integrate some of those rich AWS or Azure cloud integrations like heightened key control and backups and log streams. And we'll also see the ability during our consortium and our network creation to actually decentralize this network, something that's really, really powerful in enterprise blockchain orchestrations. Okay, so here I am. I have a Kaleido account, a Kaleido organization. I've logged into the console, and I'm going to go ahead and create my business network. And these are arbitrary strings. You can name your consortium, your network, anything that's reflective of your use case, of your vertical, and of your business network. So I'm just going to call this testnet. And you could upload some legalese or some rhetoric describing the point of your business network. And now you're going to go ahead and set your home region. And by extension, you're going to whitelist this cloud provider and this region. And we see here now that I'm on my business subscription or on an enterprise subscription, I'm going to have the ability to whitelist multiple regions and multiple cloud providers. So this can not only be sort of a global network, but this can be a global and cross-cloud network. So I can grab all the regions in AWS, and I can even grab the Azure regions. And when we go to create our nodes and do our integrations, we're going to be able to run the containers in these data centers, and we'll be able to integrate services that we have hosted in those data centers as well, like log streams, like backups, like private traffic, for example. So I'm going to grab the whole kit and caboodle, whitelist every cloud provider. And we also have support for running these nodes, Ethereum nodes and Corda nodes in your own private cloud in your own on-premise data center. So if that's something of interest, that's our Kaleido private stack offering. Please reach out, and I'll provide all of the URLs and all of the email addresses that you can use to get more information about those programs as well. Okay, so here's the container. Here's the namespace for our business network. It's not very interesting. It just has me, Alpha Organization, as the first organization. And now we can kind of go one of two routes. So a really useful and efficient pattern in the early stages of networks is to mock out what it's going to look like at the end of the road, right? And so rather than actually decentralizing it from step one, what you can use is this construct that we have called a membership, to sort of simulate how that network's going to look in the end. And you can start binding resources and security credentials and all of the core services to these different memberships. So again, you can simulate, that ostensible ownership of those assets. So I'll call this Bravo organization. And again, now we can create nodes and services and we can bind them to these memberships, but I own both of them. Now, the other route you can go, now that we've GA'd Corda, is you can use our business and our enterprise tiers and you can decentralize your network. So you can actually, as the founder, send an email invitation via the console or via the API, and you can actually onboard another entity. So maybe this is organization 123, this could be a bank, this could be a supply chain partner, this could be a NGO, any sort of entity that makes sense in your business network. You would send an email to the sysadmin for that company, for that organization. And then now you, as the founder of this consortium, of this business network, you can allocate and you can rescind permissions. So we're giving you the ability to do role-based access control at the network level. Then when we go down into the application level, you can start doing more granular, more blockchain layer things. This is the macro permissions, I guess, so to speak. We see that there's 5 very self-explanatory permissions. Do they have the ability to manage environments, upgrade environments? Can they invite other organizations? Could they create multiple memberships? Or could they use the smart contract management feature that we have? So these are always going to vary based on your business network, based on the scope of it. If you do want to decentralize it, but you kind of want to maintain one benevolent dictator, so to speak, that has all the root level permissions, there's a mix and match for every scenario. So we give you the ability to allocate or rescind any of the permissions that make sense there. Okay, so there's the network piece. We're good to go here. Now we want to transition and actually create one or more blockchains underneath the umbrella of our business network. We call those environments. That's our nomenclature in Kaleido. And needless to say, going hand in hand with standard DevOps techniques, you can have multiple environments, multiple blockchains under the scope of your business network. So you might want to have a sandbox, you might want to have a dev, a user acceptance testing, pre-prod staging, and then production. And we create sort of all of the rails and all of the transport layers to very easily promote code and promote your application without having to do a lot of re-architecture or reprogramming. There's one rule of thumb in Collido is there's really no throwaway work, right? You can start on our free tier and you can maintain and persist all of those resources as you harden and as you upgrade to different tiers. Same goes with, just sort of your basic smart contracts in the scope of a business network. Okay, so we see that we have 2 doors to go through here. Another cool thing is that you could have an Ethereum network and you could have an Ethereum blockchain and a Corda blockchain underneath your consortium or your business networks. You can experiment with both of these powerful enterprise blockchain technologies. Today, we're going to go through the Corda door, of course. So I'll choose Corda. Now I'm going to choose a name for my environment. I can call this Sandbox, Dev, UAT, what have you. I'll just call it Sandbox. We're going to choose the orchestration model. Do we want this to be cloud only, or do we want support to run one of these containers on premise? If you do, just reach out to us and we can talk through the private stack program. For ease of use, I'm sticking with cloud only, going with Corda OS and a managed notary. That'll be our system monitor node. And now we have the namespace for our blockchain environment. And what we can do is we can bring it to life by creating some Corda nodes. So I'll create one apiece for each of our memberships, Alpha and Bravo. And what we're going to do is we're going to do an IOU example where we have the Alpha organization acting as the lender, and we'll have the Bravo organization acting as the borrower. So first one, we'll create a node for Alpha, N1, node number 1. Choose where I want it to be deployed. I'm going to leave them both in Ohio, in Columbus, Ohio, but we see I could send them anywhere around the world here. Click next. I can now choose to integrate with some of those rich, cloud services like backups or log streams or private traffic. Again, this is another advantage of Corda being GA. You can use this in tandem with your business and enterprise tiers. And then based on the traffic, based on the chattiness of your application, you can choose different Corda node sizes. So how many connections do you need to have? How often are you sending transactions through? What's the request per second metric? So based on those thresholds, you can choose accordingly, small, medium, or a large node. I'm going to go with small because we're going to do a very, very simple DApp here. And now I'll just create a node for the Bravo organization, N2, and I see that I have the same choices. I can choose the cloud and the region, and I can choose any of these integrations, backup streams, or private traffic. So we'll leave that guy as a small node as well. and these guys will take about 45 to 60 seconds to come up. So what we're going to do here during this walkthrough, during this demo, is I'm pretty much going to go lockstep with our Corda quick start guide here. And you can find this inside of the documentation, docs.kaleido.io, using Kaleido, Corda quick start. And this will hold your hand through every single thing you need to do to, create a client driver, create an RPC client, to actually grab some of the business logic, those jar files. It'll package them up for you. We'll give you every piece of dependency that you need, along with, hand-in-hand instructions here. So this is going to leverage our Kaleido Corda samples gallery, and this has all the source code for pretty much what you need to do to run through this project. So if you guys are interested, this is sort of the easiest happy path. Just go to the Corda Quick Start Guide, and this will redirect you to our open source GitHub repository with all the Corda samples, and you can download all the dependencies and all the source code that you need there. Okay, so hopping back here, looks like these guys came up pretty efficiently. So we have our system monitor node, which is going to be acting as our notary, and then we have the alpha node, node number 1, and we have the Brava node, node number 2. So I'm going to go ahead and click on View Node. And the first thing we're going to do is we're going to create a smart contract project. We're going to create a wrapper that underneath is going to have our business logic. It's going to have our IOU jar files, our contract, and our flow file. And you can do this one of two ways. You can actually go back to your business network tier, and you can use this shared assets class that we have, and you can create a contract project there. Or you can do this directly within the scope of your environment, which is potentially a bit cleaner and a bit more efficient. Doesn't need to sort of decouple the fact that you're in an environment and you have a business network sitting above you. So I'm going to do it within the scope of our environment. And what we'll see is that it's going to teach all of the nodes and all of the members about this shared piece of business logic, this shared source code. So I'm going to create a new contract project. I'm going to call it IOU. And now I'm going to go grab those 2 jar files that we need, our IOU contract file and our IOU flow file. So bear with me as I navigate through my directory here. Corda demo library, Corda sample. So this is the clone of that GitHub repository I just showed you guys. We'll go to the IOU contract, go to the build, go to the libs, and first we want the contract jar. So we'll grab that guy first, click finish, and then we'll grab that flow file and we'll put it sort of as a brother or as a sister inside of this contract project. So I'm going to click add core dep again, and now I'm going to choose my IOU project, and I'm going to go grab that flow file instead. So going back, Corda samples, go to the flow folder, build, libs, and our flow file. And these are our 2 core pieces of business logic that we're going to need to complete this end-to-end IOU flow. And what we'll notice now is if I go back to my business network and I go to my shared assets and my contract projects, I'm going to see the existence of those compiled jar files right there. So we can click on them and we can actually see that they've been promoted into our environment, into my sandbox environment that I created. Okay, hopping back to the dashboard, looks like our system monitor is joined and started. Okay, so a little bit of funny business there. We're good to go. So now what we need to do, we need to actually promote those jar files into the core runtime of our nodes. As it stands right now, they're sitting in, they're kind of in the waiting room. They're in a staging bucket. What we need to do is actually promote those into the node. We need to restart the node and let the Corda nodes, both of them, actually properly load these jar files. And one really critical thing to do is to make sure the node is fully initialized before you restart it. Meaning you want to make sure that it has this as the tail end of the log, running P2P messaging loop. If you don't reach that state, you can kind of get into this this little bucket of limbo, basically, where the node is never going to properly initialize. So before you restart it, definitely ensure that it's in the P2P messaging loop. Node 1 was good. Node 2 is good. For newcomers to Corda, when the node initializes, there's always a fairly clever pun hiding in the logs somewhere. So if you need a cheap laugh on a Monday or a Tuesday, you can scroll through the logs and find what joke they put in there. These are scrolling pretty slowly, so we'll skip that for the time being, and we'll just go back to sort of the task at hand, which is now to promote these jar files and to restart our node, to reinitialize our node. So I'm going to do this for node number 1, promote both of these, and click restart. And then I need to do the exact same thing for node number 2. because this person, this node, this organization is also going to sign a transaction, send it to the notary. They're going to acknowledge that they're the borrower in this scenario. So again, we'll go to the core debt management, promote, and restart. And while these guys are restarting, we can do some other heavy lifting, get all of the other services and components that we need to run the application. Once we've done that, these nodes should be properly reinitialized as well. Okay, so hopping back to the blockchain dashboard and hopping into node number 1. Now, one really critical thing that we need to create is we need to create what we call a Kaleido Network bridge. So there's no public-facing RPC connection for the Corda node. We need to get down to that TCP/IP layer. And so in order to do that, we've created a bridging technology where you can have essentially a local runtime, a local executable that can then connect securely back to a Kaleido bridge, and that will do the low-level networking, the low-level processing of those transactions, of those calls to the TCP port. So this is the next step that we need to do, is we need to create a network bridge. And so there's really 4 pieces that are going to be running here. If we sort of look from the far right to the left, we're going to have on the far right an application. Then next, we're going to have a local copy of this bridge, a local executable. The third piece will be the Kaleido hosted bridge. And then the fourth piece is our Corda nodes, our actual low-level blockchain connections. So the first thing we need to do is we need to create the Kaleido hosted service, and then we can download a binary, we can download an executable that will allow us to run the same component locally. So I'm going to be connecting through node number 1. Which is the alpha membership. So I need to have this service bound to the alpha membership as well. So we'll call this Nick's laptop because that's really where I'm connecting from. Nick's laptop to this hosted service here, and I'm going to leave it in Ohio. And what we'll see here when this provisions is we'll see that I have the ability to download a configuration blob, just a JSON definition that has all of the ingresses, all of the endpoints, and it's going to have some embedded security credentials that are going to allow our local executable to have that secure TLS connection to this hosted component on Kaleido. So essentially, we'll run our local component, we'll teach it about that configuration file, that will allow it to securely connect back to Kaleido, and then we'll target our application at the locally running bridge. And this will become a bit clearer once we actually look at all these components sitting next to each other and sort of the hops that are going to occur when we send in a basic transaction. Okay, so now we can go ahead and click Connect Network Bridge, and this will provide us with those core security credentials, what we call application credentials, and it'll provide us with this JSON configuration object. So we'll call this Nick's laptop alpha. Again, these are arbitrary strings that you create for services and you create for app credentials. If you're going to use multiple ones, it's useful to have intuitive naming conventions. So here we see the username, here we see the password, these are the app credentials. We'll give you the inline string, or we'll give you the base 64 encoded auth header. But what we're really concerned with is we're concerned with this configuration object, this JSON definition right here. And this is what's going to teach Kaleido, this is what's going to teach our local executable about how to talk to Kaleido. So I'm going to go ahead and click download. And what we'll see here is, let me close that other dummy editor. So here's basically our client. Here's the server, the Kaleido hosted bridge. Here's the actual WebSocket endpoint we're connecting to. Here's the username and the password. And then we see our other pertinent mappings, our notary, node number 1 and node number 2. And what we're really concerned with is sending our RPC calls ultimately to this TCP port right here. So this is what we'll be targeting in a local host executable on our machine right here. And this will get routed again into the Corda runtime layer via the Kaleido private stack bridge. Okay, so we have this U0I, saying that from my own memory, and then we have the ability to actually download just a mere copy, the same executable that Kaleido is running on your behalf, so that you can run this locally. I've already done that. This is very straightforward, just based on your OS. Go ahead and grab the right tar or zip file, and very, very easy to run this component. Again, this is documented ad nauseum in the quick start guide, so there shouldn't be any issues with this component. You really just need to download that executable. Okay, so this is where I have it running right here, KLD Bridge Mac 64, and then I have my actual application client running over here on the far right. So the first thing we're going to do is actually just export an environment variable to teach our local executable, our local bridge about that file, about that JSON file. So we're going to call this tunneler config, and I believe it was U0I, I hope. Okay, it was. So that's good. And now we can just go ahead and kick this off. And we'll see that this is going to go ahead and connect back to Kaleido right here. Okay, so we're good. It's connected to the private stack server, our bridge server that we have running. So again, for context, this will be the application tier. This is the locally running executable. On Kaleido, we're running a hosted network bridge. And then ultimately we have the Corda nodes, which we created from step number 1. So those are the hops that we're going to take here. Okay, so going back to our blockchain, let's check on our nodes. Go to node number 1, check the logs. Okay, so we see that it loaded the 2 core dApps right there, and now it's back in its happy state running the P2P messaging loop. Let's do our due diligence for node number 2 as well. It has also loaded 2 core dApps, and it's running the P2P messaging loop. Okay, so we're almost home. The last thing we need to do is we need to create a username and a password for our application to speak to our Corda node. So we actually have 2 layers of authentication here. We have the Kaleido sort of application credentials TLS connection connecting the local executable to the Kaleido bridge, right? And now we need to have Corda specific usernames and passwords that have some embedded roles and embedded permissions dictating what this application, what these calls are and aren't allowed to do. We're going to go with root permissions, but you'll see that you can get a bit more granular there as well. So we're going to go to this user management tab here, and we're going to go ahead and create our first user. I'm going to go very simplistic here, just call this user 1. I'm going to give it an arbitrary role called transactor, and I'm going to create my own custom password. Of course, you can let Kaleido create that entropy for you as well if you prefer. So here's user 1. We see a notification that I've created a role called transactor, but there is no role defined. So we're going to go ahead and create that role now. Transactor, and I'm going to give it all the root permissions. And again, this is where you can get into those more fine-grained, granular application-based RBAC permissions. But for the sake of simplicity and kind of seeing this flow end to end, perfectly fine, just allocating kind of those super admin pseudo permissions there. Okay, so those are all the core pieces that we needed. Just to recap, we created 2 Corda nodes. We created one for Alpha. This is going to be our lender. We created one for Bravo. This is going to be our borrower. We stood up a Kaleido network bridge, which is going to give us that low-level TCP connection into the Corda node. We stood up a local copy of that bridge. We downloaded the executable and we taught it about all the pertinent endpoints and the security credentials. And then we used this Kaleido Corda samples gallery to build our jar files and build our actual RPC, our application client driver. So I think that's a good recap. Oh, we also uploaded the jar files to the nodes, and we restarted the nodes to allow them to load those jar files and properly reinitialize. So that's the whirlwind tour of everything that we've created. Now what we want to do is we actually want to kick off this issue, borrow, lender flow that we have here. So over here, this is the application driver. This is the RPC client. So we can see the available flags that we have here, and we're going to use a handful of them. We're going to use the URL, where we're going to specify localhost 40,031. That's going to get us to node number 1, the TCP connection. We're going to specify the username -n. That'll be user1 that I just created. We're going to give it the password, which is not very interesting that I created. And then we're going to call a method inside of the contract, inside of the flow. We're going to call the issue method. Okay, so let me clear this and we can go ahead and kick this off. And pay attention over here. This is where we're going to actually see the connection to node number 1 getting proxied through the Kaleido hosted bridge. And we can look at the actual resource IDs to confirm that it is going to node number 1. So first thing we want to do is kick off this RPC flow. So we're going to say issue -u is localhost 40031, -n is user1, and -p for password is password1. That looks good to me. Let's go ahead and kick it off. And what it's going to do is it's going to connect over here. So this is the ID for node number 1 for MR. And then it's going to prompt us to say, okay, well, who's the borrower in this flow? We know who the issuer is. That's you. That's the person that's kicked off this application. But we need to know who the counterpart is because they need to sign this transaction, send it to the notary as well. So what we need to ascertain here is the node ID of node number 2, our borrower, our Bravo organization node. So we know that 4MR is node number 1, so it's either 1 or it's 2. So we can click on node number 1. We see that this guy is 4MR. Now we can click on 2, and we see that this guy is KRC. So all we need to do is pass that integer. So KRC is number 2 right here. And this will allow the flow to properly complete. So both of these parties are going to sign those transactions, send them to the notary. The notary is going to return them, and they're going to store them in their private state vault. And this usually takes 23 or 24 seconds for all of those hops and all of those transactions to be properly signed and properly returned. So my guess is 20, it was 20. Okay, so it's quicker today. All right, so this gives us a little bit of information. If we sort of want a cleaner readout of everything that happened, what we can do is we can call the query method against the transaction hash against the ID right here. So I'll go ahead and copy that on the clipboard, clear this so that we can see, and then we'll just do a very similar call. Instead of issue, we're going to call query. We're going to go to the same URL, localhost 40031, same user 1. Let me move my Zoom bar, bear with me. Same password is password 1. And then we just need to pass that ID as the last string right here. Looks good, and that should give us a cleaner readout. And we'll see a connection happen over here again, back to node number 1. Oh, I typed in something wrong. Okay, so, well, forgive me for screwing that up. Not sure what I did wrong there, but it's a very simple query method that you can pass where you just need to, again, specify the local host proxy, the 40031. Instead of calling issue, you're calling query, and then you're doing that same authentication, user 1, password 1, and passing that transaction ID as the last parameter. So, okay, that was fairly efficient. Did that in about 20 minutes. Shouldn't take anyone any longer to do that, to do the whole end-to-end flow. Again, we have, very, very thorough quick start documentation. We have the public-facing Kaleido Corda samples gallery. And yeah, we have all of the embedded runtime infrastructure that you need, as well as, the ability to now run this on the higher tiers, on business, on our enterprise tier as well. So I meant to mention at the beginning, if there are questions, please raise your hand, use the Q&A, use the chat. We do have our head of protocol on the call today. So I'm going to use the next 10 to 15 minutes as a window for folks to potentially ask him some questions. Any questions go. There are no bad questions in this ecosystem whatsoever. So if folks do have, any low-level or high-level questions about, Corda on Kaleido, about just Corda generalistic questions, please don't hesitate to reach out. So I'll let Jim speak a little bit here, and I'll go ahead and, I guess, ask the first question of, Jim, do you want to just give like a very 101 high-level comparison of Ethereum and Corda and just point out the similarities and the core differences?
Yeah, absolutely. Thanks, Nick. That was a high-powered whirlwind tour of going end-to-end with Corda. I don't think anybody can go any faster than what you did there, but it's great to watch. So Corda, Kaleido supports Corda as the second protocol we have on the platform. We've been supporting Ethereum for a very long time, more than 2 years. And we've got a lot of experiences running Corda for customers as well. So obviously we have to understand the protocol stack inside and out to be able to provide proper support. And now we've got the opportunity to compare two of the three most prominent enterprise blockchain protocols. The other would be Hyperledger Fabric. I think Corda is a very different kind of protocol compared to Ethereum, both from how they came about, as well as what's their main focus in terms of the overall experience. So Ethereum, as we know, came from public blockchain. So they're designed to have a very, as low as possible kind of threshold for entrance, because they want developers to be very innovative, using this technology to fulfill a novel idea they may have in their head. So Ethereum emphasize making it very easy to create a contract, create a dApp, and start doing stuff on blockchain. Corda, on the other hand, is born out of enterprise space. So security, IT checklists is very high on the list in their design principle. So it's very robust in terms of security and permissioning. At the same time, it's also it takes also more setup to get a Corda network running. There's a whole bunch of certificates you have to issue to get a Corda node joined together on the network. As far as the programming model, the role of the client plays a very different role in Corda versus Ethereum. Ethereum has on-chain, which is the smart contract containing the business logic of processing transactions. And then a lot of workflows may take more than one transaction to fulfill. Multiple parties may need to submit their own input in order to carry a business transaction through end-to-end. So the client has to do the initiation of those transactions, and each party have to use the client to submit their own transactions. So the client plays a pretty important role to coordinate the different steps and call the on-chain functions. Corda tries to make everything go on-chain. The coordination side is also on-chain, unlike Ethereum that's left to the client. Corda has a flow framework where multiple steps from multiple parties involved in the business transaction are expressed in code called flow. So, and that's also deployed on-chain along with the transaction themselves. So in Corda, clients can be pretty thin. They just trigger a flow, and the flow is responsible for making sure all the steps involved in the transactions are carried out. And the client just waits for the transaction to go through. The third angle I'll mention is the signing key. So all distributed ledgers or blockchains rely on digital signing to make sure transactions are identified. So Ethereum has nodes, and then they have wallets. So nodes are just responsible for taking transactions that are and validate that they're properly signed. And then wallets contain keys, and they're typically separate from the nodes. Some Ethereum implementation have wallets built in, but wallets as a architectural construct is a separate thing from the node itself. Corda again tries to make that integral together. Corda nodes have built-in signing keys, and signing keys are not separable, at least at the current stage from nodes. So you don't really have to manage separate wallets as a different component because they're built into nodes. So hopefully, design principles, roles of the clients, and roles of the wallets and signing keys, those are three main angles you can compare Ethereum versus Corda.
That's great, Jim. Thanks for that high-level comparison. Okay, doesn't look like we have any additional questions from the audience. So I think what we'll do is try to give everyone 25 minutes back of their day. I'm going to leave some contact information inside of the chat. If you guys do want to discuss, for example, on-premise deployments with private stack, if you want to, look into sort of this early pilot program of Kaleido helping run your core dApps for you on your behalf. If you want to explore any of those early stage pilot or POC packages, any of the above is available. So sales@kaleido.io. I'll give my personal email. If you have a technical question, you can always open a ticket at support.kaleido.io. And you can reach me at my email at nick.gaske@kaleido.io. So again, happy to cover any technical or any commercial topics of interest. We thank everyone so much for joining today. Please don't hesitate to create a free starter account and try out Corda or Ethereum for yourself. And you can always reach us inside of the product, inside of the console, or at any of these email addresses, URLs that I shared. Thanks to Jim for chipping in and giving us some SME expertise. And again, hope everyone's staying safe and staying healthy. And we look forward to helping you on your blockchain journey. So thanks again, and stay tuned for new topics over the course of November and December as well. Have a great Tuesday, everyone.